Welcome back, students. From this video we are going to discuss what is the definition of a isomorphism of a graph. It is very important definition, and many times is given in the external examination. So isomorphism of graphs definition: the simple graph g1 equal to v1 e1. I have taken a graph g1 equal to v1 e1. Graph means simply it consists of vertices v1 and edges e1. So G2 equal to V2 E2. They are isomorphic. When they are isomorphic means here it is a bijunction. It must be a bijunction. That means bijunction means we already know that it must be a one-to-one and it must be a onto function. If it satisfies one-to-one and onto function, then it is called as a bijunction. So it must be a bijunction. So F from V1 to V2 with the property that A and B are adjacent in G1 if and only if f of A and f of B are adjacent to G2. So this is the condition of a isomorphic of a graphs. So simply we can take that one graph G1 equal to V1 E1 and G2 equal to V2. These are isomorphic if and only if they are bijunction. Bijunction means they must be one-to-one function and onto function. From function mapping from V1 to V1 and the property that if we take f of A and f of B, it must contain a value of A and B. Then it is said to be isomorphic. Such a function is called as a isomorphism. In other words, simply we can say that G1 and G2 are isomorphic if their vertices can be ordered in such a way that adjacency matrices mg1 and mg2 are identical. Then only we can say that it is a isomorphic graph. So here the simple graph G1 equal to V1 E1 and G2 equal to V2 E2 are isomorphic if they must have, first point is it must have same number of vertices. That means the two graphs must have same number of vertices. That is the first point. Next point is it must have same number of edges. Third point is it must have same degree of vertices. Then we say that it is two graphs are isomorphic. So the condition for isomorphic of a graphs are, if we take two graphs, we can decide the isomorphism between two graphs. If we consider two graphs, one is G1 equal to V1 E1 and another one is G2 equal to V2, and we say that these two graphs are isomorphic if they must satisfy the following three conditions. Those are: number one, it must have same number of vertices. That means the both graphs have same number of vertices, and the both graphs have same number of edges, and the both graphs have same degrees of vertices. Then it is called as isomorphism of a graphs. So here I am considering one example. See, I have taken a problem here. Now I will prove that these two are isomorphic or not. So before proving that, we have to put in mind that whether they are isomorphic or not. So we can simply see how many vertices are there between two graphs. See, from this graph I am having vertices 1, 2, 3, 4, 5. So here I am having, from this graph I am having 5 vertices, and from this graph I am having 1, 2, 3, 4, 5. Yes, first condition is satisfied. So number of vertices from this graph is equal to number of vertices from this graph. So first condition is satisfied. Now I will check from number of edges are there or not. So here one edge, 1, 2, 3, 4, 5, 6. Here from this graph I am having 6 edges. Now if this graph also have 6 edges, then they are isomorphic. 1, 2, 3, 4, 5, 6. Yes, they are having same number of edges. So they are having same number of vertices as well as they are having same number of edges. So we can say that it is isomorphic. But simply we cannot say that it is isomorphic. We have to see another conditions also. So what are those conditions? Yes, they are isomorphic because they can be arranged to look identical. They both are represent identical. They are both are same. You can see this in the right graph. You can move vertex to B to left and from edge from A to C. Then they are isomorphic. They are isomorphic means it is having the same properties from this graph to that graph. If this graph is having the properties like this, then this graph also is having the properties like this. If f of A equal to E, then here f of A B equal to A. If f of C equal to B, f of D equal to C, and f of E equal to D. So it is having the same properties of this graph, and it is having the same properties of this graph. So they both are identical. So they both have the same degree. So we can easily say that these two graphs are isomorphic. What about how does these two graphs represent? So they are not isomorphic. How can we say that they are not isomorphic? First of all, we will check whether their two vertices are equal or not. Here for this graph, 1, 2, 3, 4, 5 vertices. For this graph, 1, 2, 3, 4, 5 vertices. So vertices are equal for both the graphs. So first condition is satisfied. Now I will see second condition. So edges 1, 2, 3, 4, 5 and 6. It is having 6 edges. So this must be also have 6 edges, then they both are isomorphic. 1, 2, 3, 4, 5, 6. Yes, the second condition is also satisfied. If the first two conditions are satisfied, then we go to another condition and see whether they are isomorphic or not. So here he has said that they both are not isomorphic. Why they are not isomorphic? Why? Because they differ in the degrees of vertices. So their degrees is separate. So if we take the degree, so suppose I want a degree from A. So the degree of A is 1, 2. Degree of A is 2. What is the degree of B? Degree of B is 1, 2, 3. So what is the degree of C? 1, 2. Degree of C is 2. What is the degree of D? 1, 2, 3. What is the degree of E? 1, 2. So I will write the degrees. And so now in this diagram I will see the degrees. So what is the degree of A? Degree of A is 1, 2, 3. Degree of A is 3. What is the degree of C? 1, 2, 3. What is the degree of D? Degree of D is 1 only. Here the degrees of E is 1 only. Here the degrees of D is 3. But here the degree of D is 1 only. So here the degrees of B 1, 2, 3. Here the degrees of E is 1, 2. So here the degrees are not equal. Here the first two conditions are satisfied. That means the vertices of the two diagrams, two graphs are equal and the edges of the two graphs are equal, but vertices are not equal. That means the edges, that means the degree of vertex are not equal. So it is not isomorphic. So first of all we have to check whether the two graphs have same vertices. If they have same vertices, then first condition is satisfied. Next one we have to check whether they have two edges. If they are having two edges same, then second condition is satisfied. Now we have to go for the third condition. The third condition is we have to check the degree of vertices. We have to check both the degree of vertices and both must have the same degree of vertices. Then only it is isomorphic. Otherwise it is said to be not isomorphic. So here the degree of vertices are not equal. So these two graphs are not isomorphic. So here he has given two and we have to check whether they are isomorphic or not. By the same conditions we can check it is isomorphic or not. So here some of the definitions are complement of a graph. The complement of a graph is G which has same vertices of G. An edge exists in G if and only if it does not exist in G. We already know that complement means it does not exist. A complement equal to 1 minus C. Similarly here also complement means. So the theorem is there, two simple graphs are isomorphic. The condition is complements are isomorphic. If complements are isomorphic, then the two graphs are isomorphic. So this is one of the theorem. Simply we can use this theorem in doing problems also. If two graphs are isomorphic, then their corresponding subgraphs are also isomorphic. So this is also one of the conditions of checking whether the graphs are isomorphic or not. So induced subgraph, here also we can check whether the subgraphs are induced or not. That means if we take subsets, then it is induced or not. If it is induced, then also we can say that it is isomorphic. So we have to check the one by one conditions whether they are isomorphic or not. So here I have taken two graphs. Now I have asked a question that show that the two graphs are isomorphic. So first of all I will check whether what are the number of vertices and number of edges. Here the number of vertices are 1, 2, 3, 4. The vertices are 1, 2, 3, 4. Here 1, 2, 3, 4, 1, 2, 3, 4, 5. So here the number of edges are 4. Here the number of edges in H are 4. Number of vertices are 4 and number of vertices are 5. So first of all the number of edges are equal. See here 1, 2, 3, 4. G is having 4 edges and H is having 1, 2, 3, 4. H is also having 4 edges. So the edges are equal. Now we check whether the vertices are equal or not. So vertices are 1, 2, 3, 4, 1, 2, 3, 4, 5. So vertices are not equal. So here in this diagrams, in the both graphs, number of edges of G and H are equal. but number of vertices are not equal. So therefore we say that the two graphs are not isomorphic. So easily we can say by the two conditions they are isomorphic or not. So next diagram. In this diagram, show that the two graphs are isomorphic. In G, first of all, I will take whether the vertices are equal or not. Next, I will consider the edges. From these graphs, the number of edges are from G are 6. 1, 2, 3, 4, 5, 6 edges. And this it is having the number of edges of H are also 4. See, 1, 2, 3 and 4 edges are there. Next, here the number of edges are not same. They both are not equal. So simply we can say that the diagrams, the two graphs are not isomorphic. So by seeing the first conditions only, we can decide whether the two graphs are isomorphic or not. If first two conditions are satisfied, then we go for the third condition, that is number of degree of vertices. And if that also is possible, then we go for subgraphs. That also is possible, then we go for complement. Similarly, we can find the isomorphic